Okay, in this video, what I'm going to do is I'm going to very briefly explain what the Coase Theorem is and why the Coase Theorem is important to the development of environmental economics, and also, most importantly, to this basic notion that we can think about environmental damages as being uncompensated damages that fall out of markets or spill out of markets. And that if we can, and we'll talk about quantifying environmental damages at length in the course, if we're able to quantify the actual value of environmental damages, then we can actually come up with some sort of compensating value. In other words, what we would need to pay the affected individuals in order to compensate them for the environmental damage that they face. And there's all sorts of issues with this, and it's not necessarily replicatable in the real world, and we'll talk about why that is. But the point is really this, is that if we frame environmental damage as a form of economic damage, then it provides us a fairly straightforward way to think about how we may come up with a solution. But before we get into it, let's talk a little bit about what we need to be true in order for the Coase Theorem to create the outcomes that it does. First off, we need to be under the sort of organization of a relatively small number of entities or economic agents, whether this is individuals or singular firms. We can't have too many people that are within the system that is being discussed, because it becomes much harder to generate the compensating mechanism as there are more people. So we're going to assume there's a small number. In fact, the example we're going to go through, there are two entities, two economic agents. We're going to assume that bargaining is costless. Sometimes this is also referred to as transactions have zero cost or zero transaction cost. It simply means that the engagement of bargaining between the entities is able to be done without barriers. So it's a sort of costless bargaining. And property rights must be efficient. We talked in class about the importance of property rights, and really that the lack of efficient property rights ends up being the root cause of a lot of our environmental problems, or at the very least, it's a way that we can frame what is one of the key environmental problems, which is that environmental damage often occurs because the economic behavior does not maintain itself on a singular property, that it moves and it spills over into other properties. In this particular example, we're going to be talking about a steel manufacturing plant, which as part of its waste produces mercury, and it's dumping that mercury into a lake, which damages a community. So that's sort of the two entities that we have here. We have a community and we have a steel manufacturing plant. And the idea behind the Coase Theorem is that we can avoid the need for government intervention in terms of bargaining, but again, we need these assumptions to be true. The Coase Theorem was developed initially by sort of an economist, political scientist, Ronald Coase, and the basic sort of thrust of why he was developing this was he wanted to come up with a market-based way to deal with what he saw as a market-based problem. And the market-based problem here is the negative externalities. So let's try to find a market-based way to achieve some notion of social efficiency. Okay, so in this particular example, like I said, we have a steel manufacturing plant that's producing mercury. They're dumping this mercury into a water source and causing damage. In this particular graph, we have the marginal benefit that is flowing to the steel plant, represented here by the blue line. You'll notice that marginal benefit is declining, so there is diminishing returns to the steel producer in terms of how much steel they produce, which is pretty in line with the realities of production. On the other side, we have marginal damage, which is represented as the community. So the community experiences marginal damage. And we can see that marginal damage is actually increasing as more and more of the mercury is released. And that's what the bottom here, this is amount of mercury released. And the idea here is that the steel plant benefits from dumping the mercury, And therefore, it's a situation where, because they benefit from dumping the mercury, because in a sense, the mercury is generated from their production. Again, this is the source of the negative externality. They have an incentive, a reason to ignore the mercury that they're dumping into the lake. And so without any sort of bargaining, without any sort of assigning of property rights, if we go into this situation, we simply say, nobody has a specific property right over the lake. There's also no way of preventing mercury dumping into the lake. What's the outcome going to be? And in that scenario, the steel plant would produce until their emissions are here at 20. Why? Because they're going to produce until their marginal benefits are zero, meaning that if I could produce more and my marginal benefits for that production were still greater than zero, I would continue to produce. But because my marginal benefits production eventually go to zero, I'm not going to produce beyond that, because there's no incentive for me to produce when my marginal benefits are less than zero. So we know that the most the steel manufacturing plant is going to emit is going to be 20 here, or we refer to as Emax, or emissions max. And again, this is without any sort of rule or regulation. The plant is going to pollute out to Emax. What this means is that for the steel plant, the benefits of production are going to be equal to the area under the curve. So A plus B plus C plus D. All of this benefit goes to the steel plant operator for producing. At the same time, at an emissions of 20, the community also faces damage equal to the area under their damage curve, which is C plus D plus E plus F. And you can just sort of see from the math here that area A, B, C, and D is exactly equal to area C, D, E, and F. And so a good thing to point out here is that the benefit from the steel plant is completely evaporated by the damage caused by the steel plant. And this is a good example of the economics of the environment, which is that oftentimes we focus so much on the economics that we forget that there's this environmental damage that is probably canceling out some of the economic benefit. It's just the damage is accruing to people who aren't benefiting, and therefore we tend to only focus on the benefits. We don't factor in the damages. In this particular scenario, it's 1 for 1. Under the scenario where the steel plant emits their maximum level, the amount of damage is completely offset by the amount of benefit. And so in a sense, there's no economic benefit to the steel plant because it's completely made up for negatively in terms of damages. So now what we're going to do is we're going to go through 2 scenarios. One scenario where we give the property right to the steel plant, and then the other scenario where we give the property right to the community. Property right here means that you're able to dictate what happens. So in other words, if we give the property right to the steel plant, they can dictate how much emissions they want to emit. And if we give the community the property right, they can dictate to the polluter how much they're able to emit. Okay, so let's start with, let's give the firm the property right, and let's see what happens without bargaining. Well, it's the exact same scenario as we just described. Without bargaining and with the property right going to the steel plant, they're going to emit out to their maximum, which is 20. And in that scenario, the economic benefit and the environmental damage completely equal each other. And therefore, the social welfare, if we look at the total social welfare of steel manufacturing, it's equal to 0. Right? It generates $1,000 worth of economic benefit. It creates $1,000 worth of environmental damage. And so the resulting effect on social welfare, when taking both benefits and cost into consideration, is 0. Now, we can look at this scenario and say, well, it's not negative, at least it's 0. But remember that the steel plant is going through a tremendous amount of effort to create these economic benefits. And at the end of the day, they're being equalized to environmental damage is clearly highly problematic. Now let's open up the opportunity for bargaining. Let's imagine that the community bargains with the steel plant. Specifically, the community is going to offer the steel plant essentially a buy-off, an amount of money that will get the steel plant to operate at a point that the community would be okay with. So the question becomes, what is the community able to pay, and where would this get us? Okay, so if we look at the situation with bargaining, recall that when the steel plant emits to its maximum of 20, the damage to the community is C, D, E, and F, right? So that's a form of damage equal to what was $1,000. So the question then becomes, okay, so what's efficient, and how much would the community have to pay to get us to efficiency? Okay. Well, if we use the first equimarginal principle, which we've learned in class, we know that efficiency is dictated by the equalization of marginal benefits and marginal costs. Well, here marginal damage is marginal cost. So we know the most efficient point of steel emissions is going to be where the two lines intersect each other. And we can see that is true here at 10, which is the middle ground between 0 and 20. So it is socially efficient for there to be 10 units of mercury pollution emitted. And so the question then becomes, how much is the community going to be willing to pay the steel plant, and would the steel plant accept that? So again, remember, the steel plant is going to produce damage to the community equal to C, D, E, and F without bargaining. The community would therefore be willing to pay area D and E to the steel plant. If they do this, notice that they avoid the damage of F, they pay D and E, and this would get the steel plant to only emit 10 units of emissions. And you ask yourself, well, how is this going to get the steel plant to only emit 10 units of emissions? Well, go back to the scenario before bargaining. We know that the steel plant's going to emit a total marginal benefit of A plus B plus C plus D. If the community pays the steel manufacturer D and E to only emit to 10, this means that the benefit to the steel manufacturer is going to be A plus B plus C, that's what they get from production, and D plus E. This is actually better than the scenario for the manufacturer without bargaining, right? With bargaining, the manufacturer made $1,000. With bargaining, the manufacturer makes more than $1,000, okay? They make A plus B plus C, and then they are compensated D and E. And so the resulting effect on society is that the steel manufacturer nets A, B, C, D, and E, and then the community nets F, and then pays D and E. So what's left is C. So if you look at this from the perspective of damage or cost, as opposed to having to pay C plus D plus C plus F, which is what they have to pay, quote unquote, when they're damaged by the environment, now they're only paying D and E, which is less than C plus D plus C plus F, and the damage is only equal to C. So from a lost resources perspective, the community loses C, D, and E, but does not lose F. And that is better than the scenario prior. And then, of course, we just covered the fact that this scenario is also better for the steel manufacturer because they get A, B, C, D, and E. And then more importantly than that, if we net out the social welfare, we'll see that society benefits $500, which of course is better than what society got previously, which was $0. So the point here is that even if we give the bargaining power to the steel plant, there is a compensating principle that allows us to reduce the negative effects of the externality without government intervention, because the community has an incentive to compensate the steel plant. Even though we may look at the situation and say, hey, wait a minute, why is the community having to pay the steel plant? That's not right. We're not worried about what's right or what's wrong. We're worried about what's rational. And if the community faces costs of C, D, E, and F with no bargaining, and then only faces costs of C, D, and E with bargaining, it's clearly better for the community to bargain, even if ultimately they're paying to reduce emissions. So now what we're going to do is we're going to give the property right to the community. Well, in the scenario where the community has a property right and there's no bargaining, the community is not going to allow any damage, because I wouldn't allow 50 cents of damage if I could avoid it, right? That's rational. And so when the community has the property right and the plant doesn't, the plant's not going to be allowed to emit anything. So there's no economic benefit. There's also no environmental damage. And therefore, the social welfare is zero. Importantly, to point out that even this outcome without bargaining, this should say without bargaining. It says with bargaining, but it should say without bargaining. Even with bargaining, or even without bargaining here, we should see that we're worse off than we were with bargaining when we gave the property right to the steel plant, which is oftentimes something that students are a little surprised by. Now, it's true there's no damage, so the community is better off when they have the property right and they don't bargain, but society as a whole is better off with bargaining. And then if we look at, if we give the property right to the community, and again with bargaining, we can see that it's a very similar scenario. The difference is that instead of the community compensating the steel plant compensates the community. So basically, it's like the steel plant is going to compensate the community to allow production. And so again, if the steel plant would emit zero, if the property right was with the community and no bargaining, then the benefits are zero. Then if you give the property right to the community and there's bargaining, we ask ourselves, does the community stand to benefit if they allow steel emissions, assuming the steel plant compensates? And the answer is yes. Specifically, if the steel plant pays the community B plus C, which they would be willing to do, the community would therefore allow the steel plant to emit to E10, which again, we've already established is the socially efficient amount. Now, the steel plant makes A, B, and C in economic benefit, pays B and C, so basically has A left over. So they benefit A, which is better than here when they didn't bargain and they got nothing. Now they get area A. And then for the community, they experience C in damage, but are compensated B and C. So they actually end up better than the damage itself. And so again, we could see the exact same scenario occurs. There's $500 in social welfare. So the key point here is that it doesn't even matter who we give the property right to. As long as there is some compensating mechanism available to two parties, rational self-interest would lead either of those parties to engage in bargaining. Now, recall that in order for this to be possible, we need these things to be true. So when we try to relate this to real-world environmental issues, especially large-scale ones, we start to lose that bargaining ability. And that's absolutely something that we are concerned about. One connection to the real world that I think is very interesting is the use of class action lawsuits in the litigation against large corporations. It's very difficult to sue large corporations, which could be thought of as a sort of Coasean bargaining, right? Coasean bargaining in the form of, I will sue you, you need to compensate me for these damages that I can prove. So a good example of this is like the BP oil spill. Okay, the problem with the BP oil spill, aside from the environmental damage it created, is that it created damage for millions of entities, recreational entities, productive entities. There were a lot of individuals, companies, communities which are damaged by the BP oil spill. And because of that, it's very difficult for bargaining to occur because you have so many potential individuals. However, class action lawsuits, which allow groups of individuals to form together to sue large entities, could be a way for us to take a situation that may seem like Coasean bargaining is not possible and actually create large groups of small numbers of large groups, which might get us closer to some of these assumptions that we're talking about here. Okay, so again, the broader point of Coasean bargaining, or the Coase theorem, is that in the context of negative externalities, there is a potential for bargaining to lead to improvements in social welfare without the need for government intervention. However, one, you need governments to define property rights. So when we say without government intervention, that's already a little bit of a misnomer, because the property rights have to be secured by a government. So that's one problem with it. And then, of course, the other problem with it is they're not usually this sort of clean. So what we'll often do in class is we'll often take ways in which we solve issues related to pollution or whatever, and then we'll say, well, let's compare it to the Coasean outcome, and we'll see how close policy and intervention gets us to the sort of Platonic ideal Coasean outcome. That's sort of what we do.